Good morning, ma'am. Good morning, classmate. So today, I'm going to answer some practice problem in Module 5, which is the joint probability distribution, sampling distributions, and point estimation of parameters. By the way, I am Ibrahim J. Acob from BSCE 2A. Now, in the question 5.3, it says that x and y are independent normal random variables with e of x equals 2, v of x equals 5, e of y equals 6, v of y equals 8. Now, it says that determine the following: a e of 3x plus 2y, letter b, v of 3x plus 2y, letter c, p of 3x plus 2y less than 18, letter D, p of 3x plus 2y less than 28. So now we're going to answer first A, which is E of 3x plus 2y. Let's go. Okay, so in here, we need to separate the given, which is it will become 3e of x plus 2e of y. Now after that, we need to substitute um, x to 2 and y to 6. Now after that is multiply it and then add it. Now that's why we come up with the answer 18. So the answer for letter A is 18. Now for letter B, just like in letter A, we need to separate again the given, which is it will become 3 of x plus 2 of y. Now after that is we need to substitute the x and y. So the x will become 5 and the y will become 8. By the way, I get that 5 and 8 from the given. Now after that is we need to multiply 3 times 5 plus 2 times 8, and then the answer will be 77. Now the answer in letter B will be 77. Okay, now let's move for letter C. Now in letter C, as you can see, we separate the given, so it will become 3 of x plus 2 of y. So put symbol of n and then n of 18, 77. Now we get 18 and 77 from the answer in letter B and in letter A. That's why we come up with p of 3x plus 2y less than 18 minus 0.5 or negative 0.5. So that's the final answer for letter C. Now let's move for the letter D. Now in here, assuming z is equals to 3x plus 2y minus 18 all over the square root of 77. Now with that, we come up with this: p of 3x plus 2y less than 28 is equals to p of 3x plus 2y minus 18 all over square root of 77 less than 28 minus 18 all over square root of 77. So just distribute the square root of 77 in the denominator of the given numbers. That's why we come up with p of z less than 1.14 is equals to empty set of 1.14. That's why we come up with 0.8729. So that's the answer for letter D. So for the next question, PVC pipe is manufactured with a mean diameter of 1.01 inch and a standard deviation of 0.003 inches. Find the probability that a random sample of n squared a sections of pipe will have a sample mean diameter greater than 1.m inch and less than 1.012 inches. So let's go for the solution. So of course first we need to write the given, which is u is equals to 1.01, standard deviation is equals to 0.003, z is equals to x minus u all over standard deviation all over square root of n. Now for the solution, we need to substitute each of the given. That's why we come up with p of 1.009 minus 1.01 less than x minus u all over standard deviation all over square root of n less than again 1.012 minus u all over standard deviation all over square root of n. Now, after that, we need to distribute the standard deviation all over n in both sides. That's why we get p of 1.009 minus 1.01 all over, which is the distributed denominator with the given. So it will become 0.00t all over square root of a, and then less than z less than 1.02, I mean 1.012 minus 1.01 all over again, which is the distributed denominator and substituted number. It will become 0.00t all over square root of a. Now after that, we get p of minus 1 less than z less than 2, and then we come up with empty set of 2 minus empty set of negative 1. So that's why we get 0.977 minus 0.159. Now subtract it, we will get 0.818. So the answer for the 6.1 question is 0.818. Now let's move for the next question. So for the 6.2 question, a synthetic fiber used in manufacturing carpet has a tensile strength that is normally distributed with mean 75.5 psi and standard deviation 3.5 psi. Now find the probability that a random sample of n is equal to 6 fiber specimens will have sample mean tensile strength that exceed 75.25 psi. Okay, now let's go for the solution. As of course, first we need to write the given. So u or mean is equals to 75.5 psi, standard deviation is equals to 3.5 psi, and n is equals to 6. Now for the solution, we need to write or use the formula x is equals to u or mean all over standard deviation all over square root of n. That's why we come up with p of x minus u all over standard deviation all over square root of n greater than 75.75 minus mean or u all over standard deviation all over square root of n. And so with that, we come up with p of x z greater than 75.75 minus 75.5. So where we are, where do we get 75.5? Now it's the mean, and it is in the given. That's why we get 75.5. Now all over 3.5. So 3.5 also is in the given, which is the standard deviation all over square root of 6. Now also we get the 6 in the given, which is n is equals to 6. That's why we substitute it to 6, and it will become square root of 6 by using the formula. Now after that, we come up p of z greater than 0.175. So after that, we get 1 minus empty set of 0.175 equals 1 minus 0.5697. Now by that, we need to subtract it for us to get the final answer, which is the final answer is 0.4306. Now this is the answer for the question 6.2. Now let's move for the next question. So 6.3, the comprehensive strength of concrete is normally distributed with u is equals to 2500 psi and theta is equals to 50 psi. Now find the probability that a random sample of n is equals to 5 specimens will have a sample mean diameter that falls in the interval from 2499 psi to 2510 psi. Now let's go for the solution. Okay, so in here, first of course, we need to write the given, which is the given is u is equals to 2500 psi, standard deviation is equals to 50 psi, n is equals to 5. Now, for the solution, we come up with phi of 2499 is less than x less than 2510, which is equals to, by using the formula, we come up with p of 2499 minus u all over standard deviation all over square root of n less than x minus all over standard deviation all over square root of n less than 2510 minus u all over standard deviation all over square root of n. Now, by that, we come up with p of 2499 minus 2500 all over 50 all over square root of 5. Now, where we get the 50? Oh, 50 is from the standard deviation, which is 50 psi, and square root of 5 is from the n, which is n is equals to 5. From the given, less than z less than 2510 minus 2500 all over 50 all over square root of 5. So we get p of negative 0.4472 less than z less than 0.4472. We come up with substituting z into an empty set, which is empty set of 0.4472 minus empty set of 0.0447. So we get 0.73 minus 0.482. Now, all we need to do is to subtract it, then we'll get the final answer. So, therefore, the final answer is 0.191 for question 6.3. Okay, now for the last question I've chosen, which is the 6.4, it says, a normal population has a mean 100 and variance at 25. How large must random sample be if you want the standard error of the sample average to be 1.5? So, let's go for the solution. So, of course, first we need to write the given, which is the given is a variance equals to 25 and theta of x, or the sample average, is equals to 1.5. Now, for the solution, we use this formula, which is theta of x is equals to standard or variance all over square root of n. Now, after that, we come up with n is equals to variance squared all over theta of x squared. Now, after that, we substitute the given, which is, it will become n is equals to 25 all over 1.5 squared. By using calculator and plotting that number, we get 11.11 or 12. So the answer for the 6.4 is 11 for 11 or 12. And so that's it, everyone. Again, my name is Ibrahim J. Jacob from BSEE 2A. Thank you for watching. Bye. Keep safe, everyone.